Welcome students. In this lecture, let us look at the different supervised learning methodologies used for social media analytics. So whenever you talk about a learning process, it is nothing but training a system with already a known history of data. So this is the difference between the supervised learning and unsupervised learning. If you do not have a target vector or a target data, then you cannot process with the concept of supervised learning. So whenever you have a social media analytics application, the first thing you have to keep in your mind is, do I have a target vector for that? If yes, definitely you can go with the supervised learning. So how does it work? So you have a large amount of training data. And as I have already told, it is pre-trained or historical data. So you also have a target vector. This is called as data pair, or we call it as a label. You have the original data and also you have the label. Put together, we call it as a data pair. We now give it to the system and make sure that our data is stored in the system. This is an iterative process. All supervised learning category methods fall under iterative process. And once the iteration is done, we hope that the data is stored in the system. How do we find that the data is perfectly stored? It is based on an error value. Each iteration will give you some error. So depending upon the quantum of your error, if it is very high, then it still needs more iteration. If it is very less, then it needs less iteration. This is the process by which we make use of supervised learning algorithms. This is a small example where you can find the original input data and the target data. The class corresponds to the target data here, and the original input is nothing but the age, the job, the own house status, the credit rating, everything. So depending upon the number of input rows you have, that many number of elements will be there in your data. So we have different types of learning algorithms. So you can here look at the general process of the learning algorithms. You have the training phase, you have the testing phase. So what happens in training phase? As I told you, the original data and the data pair will be given to a learning algorithm. So far this will be only a computer program. So once it is learned, or we say that the training process is over, now this is called as a model. So this model is capable of doing the same application. Say, for example, classifying yes or no in the previous data history. So now we take a new data and check whether we are going to get the same possible output depending upon the patterns which are available in the system. If you are getting a wrong data or a wrong answer, then it indirectly indicates that the training process is not proper. So you have to go back and make sure that you train again. Additionally, the problem may not be on the training. Sometimes the problem may be also on the data. As you know, the social media data is full of heterogeneous data, so it is very complex. Probably you may need some amount of data pre-processing too, a data cleaning, a removal of data entry, a confusing data removal. So many types of data cleaning process or data pre-processing process are there. Maybe you can adopt some and then you can go for the training or the testing process. You have several algorithms. The simplest algorithm is the decision tree classification algorithm. So how do I classify the previous data which is given to me? So initially I convert this into two groups, probably positive one or negative one. So the threshold or the line should be in such a way that there will not be any misclassification of data. With a single division line, I have two groups. Now within a group, again I go for subdivision and this process will keep on continuing. Each time I will check whether the error is less or error is high. If the error is less, then it is indicating that my division of the groups are perfect. So I go on with the process till I reach the end stage of the tree structure. This completely forms a tree structure and each time we are taking a decision. That's why this methodology or this classifier is called as decision tree algorithm. This is one of the simplest algorithm which you can experiment for your social media analytics applications. Welcome, students. In this lecture, let us look at the different tree pruning and the overfitting methodologies. So, whenever we talk about decision tree, we are going to grow the tree to a larger extent. But what happens here is the tree size may become extremely very large, which may cause huge computational complexity to the users. So, how can we avoid that? So, one process to avoid that is called tree pruning, where we are going to cut some branches in the tree as we do in the real-time situations. So what happens here is we assume or we evaluate the different tree branches capabilities, or otherwise we can say we are going to measure the entropy or the gain of those specific branch, and if it is found less, then we can say we are going to remove that specific branch. This is called as tree pruning. Now, this will not affect the overall process of the system, because once the gain or the entropy is less, then probably the trees are not with that specific um, output or specific branch for their application. So this is the way how you can visualize the decision tree process. You can see first there is a two cut which is done in the first figure in a vertical direction. You can see many black dots and white dots on the other side. Then you will go for the second cut, where again you are going to classify the white dots and the black dots. And again with the black dots, again you are going to make a cut with which you can separate. So all the black dots as per this figure, or all the white dots, will come under one specific category. This can be mathematically evaluated also. We call it as Gini index or entropy. Any one of these performance measure can be used for the process. Now, how do you evaluate your classifier? There are many process by methods which we can evaluate the classifier. One among them is the performance measures such as classification accuracy, sensitivity, specificity. But again, the question here is you are choosing the training samples on your own for the training process. What happens if another set of training samples were chosen? Probably the results may change. To avoid this, we have a process called as cross-validation. So what happens is the entire training data set is, say for example, divided into four times. When it is divided into four times, at a time, one set of training sample is made use for the process. Then in the second, third, and the fourth time, the other samples are made use of for the process. So you will not face the biasing or the partiality given to the samples, but each time you will be given an idea how the samples were overloaded from one stage to another. Or we can say four times the experiments will be repeated and you will get the results four times, and the average of the results were chosen. These are some of the common performance measures, the true positive, false negative, true negative. These measures are identified from how successfully your data is classified. If we are expecting a positive result and your methodology also says true, then it is put under TP category. If the reverse, we say it is TN category. False positive or false negative are the two things where the contradictory happens during the prediction system. Once you calculate the TPT and FP, FN values, you can see the formulas precision recall, which is dependent on true positive. However, when you look at the other measures like the accuracy measures or the F measure, you can find out how performance varies over different levels of threshold in a time. So these are some formulas which are giving you answers in the form of numbers, but there are also graphical illustrations with which you can come to a result, which we call it as ROC curves. So it is a graph between the sensitivity and specificity, and each time when you are going to measure the threshold changes, so the sensitivity value changes, so the specificity and the sensitivity graph direction also will change. Based on how they are moving close to the y-axis, we are going to say that it is perfect. Welcome students. In this video lecture, let us look at the concept of clustering. So there are two types of supervised learning procedures, supervised and unsupervised. The two types of applications of supervised are segmentation, classification, regression. Now we come to the concept of unsupervised learning, where there are another two applications which are called as clustering and association. So these processes are also used for social media analytics. The major application among these two are clustering. So what is this clustering all about? It is the process of organizing data into groups where members are similar. So now when you look at this definition, you may get a confusion between classification and clustering. Are these two things same? They look same, but they are not actually same. So how do we find the difference between these two? Whenever we talk about classification, after the training process, the machine is going to give you the full-fledged output with specific details. If it is a dog, it says it is a dog. If it is a cat, it says it is a cat. But when you come to the clustering process, clustering is nothing but only grouping. That means you will not be able to find out the narrow details available or the specific details available within the application. It will give you generally, say for example, I want to give some offer to the mobile. Assume I am a mobile company and I want to give offer to the people who are using different types of my data packs and the voice calls and other things in a specific region. So how do I do that? I can find out the people who are using the specific differences in the applications. That is not necessary when you go for your other types of applications such as classification. You have only the general item here, but not the specific. So I do not want to find out who is using 3 GB data or 2 GB data. I just want to find out that 10 people are using 3 GB data or 20 people are using 2 GB data. So such type of applications predominantly make use of clustering. Specifically in Facebook, we try to find out who are friends with other people, or who are the people with more number of friends, or we are seeing many groups in Facebook. So maybe your school group, your college group, or whatever it may be. How will the machine identify these people are under the same category with the help of this concept of clustering? So again, clustering has many challenges. It's not that easy because we are going to differentiate objects based on their shapes only. So what happens if my selection of shape is wrong? There may be more than one object with the same size and shape. If that is the case, definitely my machine is going to make mistake. And at the same time, there is another challenge which we commonly see in clustering is the size and the shape of the object may vary from time to time. It may disintegrate, it may change. Look at the chair. 50 years back, the chair's shape is different. Now look at the shape of the chair. You will find plenty of shapes which are available for different applications. So selecting the correct size and shape or the similarity measure or the objective function in clustering is very, very crucial. If you do not do that, the probability of you ending up with the wrong answer will be very high. So these are some examples for clustering applications. How do you group maybe pet animals, domestic animals? It is clustering without specifically pointing to anyone. Or if you say final year students, third year students, again that can be grouped under a clustering application without pointing to any different specific features. So everything is based on some characteristic features or similarity measures. Once you click the correct similarity measure, definitely you are going to do a wonderful social media